All right, guys, Greaves back with you. All right, so going to talk about, I guess, a couple things here with you today. I'm going to send you to that website again just to play around, and then afterwards I'm going to ask you to go take a look at a YouTube video with someone who's actually playing around with that website for the second part. It's going to be hard for me to explain what I want you to do for that part, right? So first part is waves. What happens to a wave, right, when it encounters a boundary? What do I mean by boundary? Well, an obstacle, right? And by the way, it's many different things. So let's just say I have a string, right? I'm going to take that string. I'm going to send a pulse, right, down the string, and I'm going to tie that string to a wall. Right, there's the wall. Now, I would say that this wall is fixed. So this is a fixed boundary. It's not allowed to move, meaning when the wave hits the boundary stays still. Okay? So what's going to happen, right, to this wave when it hits the boundary, right? Well, if you say it's going to reflect back, you are correct. So when this wave encounters this wall, we are going to get a reflected wave come back. Now, the question in this particular case is, how is it going to come back? Okay, so the wave, I'm looking at it, this is up, right? So this is on the top of my string. This would be on the bottom. So how would this come back? Well, this wave here, I'm going to draw it, right, would hit the wall, and it would reflect back this way, but it would be inverted. So in this particular case, the wave is reflected and inverted, right? Not that you need to worry about it too much, but I'm just going to give you the basics, okay? So in this particular case, it do, in fact, get a reflection. So here's one of our standard little laws here, right? Or things that we all observe, right? All waves, when they hit a boundary, will reflect, right? We get reflection. Okay, in this particular case, it is in fact inverted. It's not always inverted. It's not something that we terribly need to worry about, I think, at this particular point, right? So let's take a look. So what always happens? Reflection, right? All right, what else could happen? So this is a fixed boundary, right? I could take another string, right? And I could tie it to, I don't know, I'm going to call this a heavy string. So let's say that this is thin, and let's say that this is heavy. I send, right, this wave, pulse, down the spring. It's going to hit this boundary. Well, what's going to happen? Well, if you say some of it's going to get reflected, you are right. So let's draw the wave, right? This part is reflected. Okay. But what about this boundary? Now, this is not fixed. This is free to move. So what's allowed to happen here? Well, if you said some of it is transmitted through, you are correct. So what happens in this particular case, since it's just another spring, it's just a little heavier, right? In fact, some of the energy, right, of this original wave gets reflected back, and some of it gets transmitted. So this would be my reflected part, and this would be my transmission, right? So what else happens? All waves, when they hit boundaries, we get transmission, right? So 1, we get reflection. 2, we get transmission. Well, what else happens? Well, one more thing happens, right? And I guess it's just a little bit of friction here, right? We call it absorption. If I sent this pulse, and let's just say it was 1 meter, right? As it travels down the spring, well, what's going to happen to the height of the amplitude of the wave? Well, as it goes on and on and on, the amplitude will get less and less and less. Why is that? Well, just friction. So what happens is we get losses, right? Right? And what do we call it? It's just absorption. Some of the wave is just absorbed in the medium. If I yell as loud as I can, someone who's a mile away is not going to hear what I say. Why is that? Because some of the energy is just absorbed in the medium, right? So couple things. Always, waves at boundaries. 1, reflection. 2, transmission. 3, absorption. Right? Absorption. Okay, so that's kind of waves at boundaries. Now, I'm going to ask you, right, to go to the website link and take a look and play around. I'll give you a specific of stuff that I want you to do there, kind of like the other day, right? So turn this off and turn it back on, right? And we're back, okay? So now, what happens also with waves? All right, so we generally, it's called the law of superposition, okay? So what is superposition? It sounds complicated, but it's really, really simple. Well, let's just say it occurs. This is a phenomenon which occurs when 2 or more waves meet in the same medium. Believe it or not, I like that show, Deadliest Catch, where the guys are out catching the crabs out in the Arctic Sea or whatever, Bering Strait. And what happens is some of those waves get to be really huge. Well, why is that? Well, I'm going to hopefully show you now. All right, so superposition, right? What is it? Well, I'm going to take some liberties here. Let's just look at this equation. A plus B equals C. It's not exactly what happens, but it's a pretty good way to start. Okay, so let's take a look. Let's suppose I have the same medium, which is a string, right? I'm going to put 2 waves in this string. I'm going to say this is 1 meter. That's also 1 meter. Let's always make the amplitude 1 meter. Let's say this guy is going to the right, and then this guy is going to the left. Let's call this A, and let's call this B. Okay? So now, what's going to happen, right, when these 2 waves meet in the same medium? Okay, couple of things. Let's recall what a wave is. A wave is nothing more than energy which is allowed to move around. Okay, energy behaves a little bit different than you and I. I'm sitting in a chair right here. At this instant in time, no one else can sit in this chair because I'm here. However, guess what? Energy doesn't behave like that. Energy, as a matter of fact, can be at the same, 2 waves, which are just energy, can occupy the same exact space at the same exact time. And when that happens, well, we get some, weird results. All right, so what's going to happen? This guy's moving to the left. I should say right, this way, right. This guy's moving to the left. So what's going to happen when these 2 waves meet? Well, what did I say over here? A plus B equals C. So when they meet each other in the same medium, right, what's going to happen is, in this particular case, I'm going to get a bigger wave, right? So now, for this brief moment in time, A plus B equals C. Okay? By the way, this happens also, one of the reasons we talked about in phase, because believe it or not, in this particular case, A and B are in phase, right? So what happens here? All right, so I have 2 waves in the same medium meeting that are in phase. So what happens is I get a larger amplitude wave. It is superposition, right? So what happens, I have 2 waves. So this right here is called constructive, right, interference. Right? Constructive interference, just as it would imply, right? I get a bigger, right, wave than we had before, constructive. All right, so what happens afterwards? Well, what happens is, it's pretty, if I didn't tell you, it might be a little confusing, right? So what happens once they meet? Well, as a matter of fact, B, which was going to the left, continues to go to the left. A, which was going to the right, continues to go to the right. It's, as a matter of fact, it's almost as if they never encountered each other before, right? So this happens, constructive interference, right? When 2 or more waves meet, which are in phase, and I get a bigger wave, okay? So what is the other extreme then? All right, let's take a look. Here I have this 1 meter again, A, moving this way, and I get another wave, 1 meter, let's call this B, but it's moving to the left. So now, I'm still going to get superposition, right? Superposition occurs when two or more waves meet. But what's going to happen in this particular case? Well, in this particular case, unlike these two waves which are in phase, these two are out of phase. So what happens when waves meet and they are out of phase? Well, for a brief moment in time, they are going to cancel one another out. So it's almost as if there's no wave at all, right? So this is called, as you would, I guess, hopefully guess, destructive interference, right? And this is a smaller wave. Not necessarily always 0. I chose my numbers, right? 1 and 1. So 1 up, 1 down, 0. This could have been 2 up and 1 down, which means my resulting wave would be 1 up. All right, well, what happens after? Well, just like before, right? A goes on this way and B goes on that way. All right? So this is superposition, right? It happens when two or more waves meet in the same medium. We could get big waves, we could get small waves, and a lot of different things. Now, I'm going to attach a little bit of a video, right, with someone who's playing around with that same exact applet, and he's going to show this to you. Okay? All right, guys. See you later.